Welcome back, folks. This is Jag0 with another video presentation. This particular presentation is covering BCD driver, ICs, decoders, and then time multiplexing as well. This is part one of the complete presentation. Now, these slides for part one were originally developed by Shahid Shabir for another module, so I've kind of used all his diagrams and kind of just modified those. So I thought that reference is important to make at the start before I get accused of plagiarism or something. Alright, now a 7-segment display is a device that has 7 LED segments, and this allows you to normally kind of display numerical digits from 0 to 9, or even hexadecimal values from 0 to F, which can be displayed on one digit. Now these are simply LEDs, 7 LEDs connected. Now the way they're connected differs from device to device. You could, this for example is how it looks. So you've got 7 segments, A, B, C, D, E, F, G, and energizing each one of these segments kind of illuminates the LED. So for example, energizing BC would kind of visually, you look at it and you say that's a 1, or energizing A, B, G, E, D would be 2. Now, an LED has an anode and a cathode. Remember, conventional current flows into the anode and out of the cathode. Now, these devices can either have a common anode or a common cathode. Let's have a look. For example, here, clearly, we can see the anodes are not connected at all, but the cathodes are all connected together, and they're taken to ground. Therefore, this is a common cathode 7-segment display. We've got a ground out. Now, all we need to energize each LED is simply a voltage on that corresponding anode, and it will be illuminated. Now, for a silicon device, for a silicon LED, it's normally 0.7 volts. It has to be greater than the cathode. The anode has to be greater than the cathode by 0.7 volts. For a germanium, it's normally 0.2 volts. But whatever the voltage is, I've kept it generic. A plus voltage at the anode is going to energize it. And we've got all the cathodes connected together. This is a common cathode connection. So, for example, connecting the supply to the anode of A will illuminate that segment. Likewise, C, AC, and that there is A5. Would you agree? We've got segments A, F, G, C, D connected to supply, and we've energized those segments, and it looks like a nice 5 to me. Okay. Likewise, we've got F there. Okay. Now, as well as common cathodes, we can actually have common anodes. Simply means that instead of energizing an LED with plus voltage, we're going to energize it using a 0 voltage. So instead of sourcing the voltage, we're going to actually sink it. Instead of sourcing the current, so the current goes into anode out of the cathode, we're actually going to sink it and take it into ground. So they've already got a plus voltage on the anodes, but the cathodes are the ones that we're going to connect. Now, connecting 0 volts to any one of the LEDs will make a complete closed loop, so the current's got a path to go from a high potential to a low potential, and as it flows through the LED, because of the material it's composed of, it illuminates and you've got the light emitting out of it. Okay, now for this one we need 0 volts, for the previous one, for common cathode, we need plus voltage, whatever that is. So I hope you understood that. It's quite important, that one is as well. Actually, we'll be covering that a bit later on anyway. Now, BCD to 7-segment display. A BCD decoder driver can be used to control and display numerical values on a 7-segment display. So these devices are driver devices that are specifically designed to display a numerical value on the 7-segment display. So, for example, in binary, if you've got 4 digits in binary, and if you've got 0001, where 1 is the least significant bit, then that represents, in decimal, that represents a 1. Well, if you actually apply that binary pattern to the BCD to 7-segment display driver IC, it will actually illuminate 1 on the 7-segment display. So BCD, binary coded decimal, actually displays the numerical values on the 7-segment display. So it does that all, and you don't have to physically kind of connect each segment to a supply voltage if it's common cathode, or 0 if it's common cathode anode. A BCD 4-bit binary number can be applied to the decoder drivers for inputs A, B, C, or D. So the BCD is converted into 7 segments A, B, C, D, E, F, and G. Each output is capable of driving directly one of the 7 segments in the 7-segment LED display. This is what I mean by a BCD decoder driver IC. We've got A, B, C, D, which are the BCD inputs. Now these could either be inputs which are connected to a switch, which gives you 0, 1, or more likely could be a microcontroller, kind of using a microcontroller to kind of generate the zeros and the ones. And at the output, whatever the binary pattern is, the output will automatically have the pattern to display that particular value in denary. So for example, we've got a little chart here. I haven't actually shown the A, B, C, D, E, F in actual values. I've just going to show them in letters. So starting with the top row, 0, 0, 0, 0, that's going to illuminate all those segments. So the only segment that's not illuminated is G, and that clearly you can see that's a 0. Likewise, that's 3, 6, 8. Okay, that's how it works. Now this is a BCD decoder driver IC, the truth table if you like, and it shows you what the outputs will be displayed as well. Now this is an example using a microcontroller. We're more kind of familiar with the PIC18F4520. It could be any microcontroller, but I just kind of wrote that one because we're used to that in embedded systems, UG2 and UG3 to follow. Now, port B, I've got 4 bits of port B which are connected to A, B, C, and D, inputs of the BCD decoder driver, and the outputs of the BCD decoder driver are connected to the 7 segments of that device. Now, if we've got 0, 0, 0, 0, that's clearly 0. Now the decoder driver will actually energize the corresponding segments on the 7-segment display, so a 0 is displayed. 1, it will actually output a 1. 2, 3, 4. So I hope you get the kind of idea here. 5, 6, 7, 8, 9. So that's how the BCD decoder driver works. Okay folks, it's a short presentation, that's about it really. I'll see you in part 2 where we'll kind of look into slightly more depth into circuits that kind of employ the BCD decoder driver circuit and 7-segment displays. Okay, I'll see you in a bit, bye.